So in the previous videos, we talked about the complex exponential, and then we used that to come up with the Euler's identity or the Euler's formula, which is e to the power of I theta is cosine theta plus I sine theta. So the real part of the complex exponential e to the power I theta is actually cosine theta, and its imaginary part is sine theta. Now, in fact, the Euler's formula is actually very useful and can be used to make many of the trigonometric identities fairly simple to work out. So let's work out one example of that. So let's say you want to find out what cosine of theta plus phi is. And it's sometimes difficult to remember all these expansions of cosine theta plus phi, sine theta plus phi. But we can use this Euler's formula to actually work out what this is quite simply. And the way to do that is, let's say you want to work out cosine theta plus phi. So consider instead the expression e to the power of I theta plus phi. Now we know from Euler's formula that this will be cosine theta plus phi plus I sine theta plus phi, because this identity holds for any angle theta. So even if you have theta plus phi, the identity will still hold. So how does this help us in working out? Let's say you want to find out what this is, and in fact, once we find out this, we will simultaneously also find out what sine theta plus phi is. So how do we work this out? Well, one of the ways is, again, one of the properties of the complex exponential or the exponential is that if you have the sum of arguments, you can actually split it up as a product of exponentials. So we can write this as e to the power of I theta times e to the power of I phi is equal to the right hand side. Now e to the power of I theta is cosine theta plus I sine theta, and e to the power I phi will be cosine phi plus I sine phi. And all we now need to do is multiply the terms out to find out the real part and the imaginary part. The real part of this expansion will give us this, whereas the imaginary part will give us sine theta plus phi. So let's work out this algebra. So cosine theta, so the real part will be cosine theta cosine phi, cosine theta cosine phi, and then we will have a real term coming from here, I squared sine theta sine phi, which is minus sine theta sine phi, plus I times, there will be an imaginary part which will be cosine theta sine phi, and then sine theta cosine phi, cosine phi, and there it is. So so the answer for what is cosine theta plus phi is, so we find that cosine theta plus phi is cos theta cos phi minus sine theta sine phi, and sine theta plus phi is cosine theta sine phi plus sine theta cosine phi. So it's sine phi plus sine theta cosine phi. So this is a fairly quick way to establishing this formula, and in fact many other formulas can also be worked out using the Euler's identity, and let's do a few more examples in the coming videos. So see you there.